So if you've ever used Google Cloud Storage, you probably think of it as, just a giant online folder. But honestly, that simple idea is completely missing the point, and it's probably holding you back. Today, we're going to pull back the curtain on GCS, break down its core components, and really show you the powerful concepts that make it all tick. Just imagine for a second you're building the next massive streaming service. You've got movies, you've got user profiles, thumbnails, all of it. How in the world do you manage all that data so it's fast, super reliable, and available everywhere, from Tokyo to Toronto, without the whole thing just crashing and burning? Well, that is the exact problem Google Cloud Storage was built to solve. And the solution, it really requires a bit of a mental shift. We need to throw out that traditional desktop model of, folders inside of more folders. Google Cloud Storage operates on a totally different and, frankly, much more powerful principle. And that powerful principle, that whole new way of thinking, it all starts with one core concept: the bucket. Seriously, for a minute, forget everything you know about folders, because the bucket is the true foundation for absolutely everything you're going to do in GCS. Okay, so a bucket is the basic container for all your data. But please, don't think of it as a folder. A much better way to think about it is like a secure global PO box. It's the one place where you manage everything: who gets access, how you're billed for storage, and even which continent your data physically lives on.
Now, of all these characteristics, the one you absolutely have to understand is the global namespace. This is a huge deal. It means that if you create a bucket and call it Michael Bucket, that name is now taken across the entire Google Cloud platform for everyone. Nobody else on the planet can use it. So as you can probably guess, your naming strategy is pretty critical.
Right, so because of this global uniqueness, you have to be really deliberate when you name your buckets. There are some very strict rules you got to follow to make sure they work correctly and, don't accidentally conflict with someone else's bucket name on the other side of the world. And yeah, these rules are strict. You have to use lowercase letters, numbers, and only a handful of special characters. Your name has to start and end with a letter or number, and you definitely cannot use prefixes like Goog or anything that looks like an IP address. Google keeps those for itself. All right, quick pop quiz based on what we just learned. Is _cloud_data 2024 a valid GCS bucket name? Just think about it for a second. And the answer is no. It fails the check because it starts with an underscore. That start and end rule is a super common trip up for people just getting started. When you create your bucket, you also have to pick its location. And this is a classic trade-off decision. Regional is the cheapest and fastest if all your users are in one place. Multi-region gives you the absolute highest availability for a global audience, but it's going to cost you the most. And dual region is that nice sweet spot in the middle for high availability across two specific areas. Okay, so we've set up our container, the bucket. Now it's time to talk about what we actually put inside it. And in the world of GCS, we don't call them files, we call them objects. An object is basically any piece of data: a picture, a video, a document. But here is the single biggest difference from a normal file system. Objects in GCS are immutable. And that just means they cannot be changed, period. This idea is so simple, but it's also incredibly profound. You never edit an object. If you need to make a change, you upload a completely new version that just replaces the old one. The original object itself is never actually modified. So why on earth would they do this? Well, it's actually a brilliant safety feature. It guarantees that a file can't get corrupted if your upload fails halfway through. Plus, it makes versioning incredibly powerful, letting you keep a full history of every previous version of an object if you want to. Now, let's talk about organizing all these objects. You're going to see paths like this all the time in GCS, and it looks exactly like a familiar folder structure. But here's the big secret. It's all just a clever illusion. Okay, this is probably the single most important concept to really get about GCS. There are no folders. It has what's called a flat namespace. That means the object's actual name is the entire string: folder1/folder2/my_file.txt. Those forward slashes, they have no special meaning to GCS. They're just characters in a really long file name. The folder structure you see is just a helpful trick the user interface plays on your eyes. So if the name is the whole path, how else can we describe and organize our data? Well, the answer lies in something called metadata.
And there are basically two kinds. You've got fixed metadata, which is stuff Google manages for you, things like the content type, so a browser knows it's looking at a JPEG, or hashes to check for data integrity. And then there's custom metadata, which is where you get to add your own special labels to help your app make sense of the data.
For example, for a streaming service, you could add a custom metadata tag to a movie file that looks exactly like this. The key is x-goog-meta-content rating, and the value you've assigned is R.
And this is where it gets so incredibly powerful. Your app can now scan the metadata of thousands of video files and, say, filter out all the R-rated ones for a child's profile, and it can do this without ever having to download, open, and inspect the actual video file. It's wildly efficient. Okay, let's bring this all together. We're going to go right back to our original challenge, building that global streaming service. So here's how all our new knowledge actually solves the problem. First, we use a multi-region bucket to get the highest possible availability. Second, we name our objects using slashes to create that simulated folder structure like genre/year/movietitle.mp4 just to keep things looking organized. And third, we use custom metadata for things like content ratings, which lets us do that powerful, super fast filtering. And that is really the main takeaway here. Once you understand that GCS uses these immutable objects in a flat namespace with rich metadata and not just files and folders, you unlock a truly scalable and resilient way to store and serve data for pretty much any application you can dream up. So I'll leave you with one final thought to chew on. Knowing what you know now, that there are no real folders, just long object names that happen to have slashes in them, how does that change the way you would write code to, for example, list all the files in a directory? It's a fundamental shift that really does impact everything. Thanks for joining me.